Hey everyone, welcome back to class. It's Monday. Video for the deductive reasoning section of our new chapter. This is kind of building on the inductive reasoning we did, where that was based on looking at patterns and trying to make a prediction. Deductive reasoning, we're going to look more at rules and facts and theories to make a prediction. But first, we're going to start with a warm up, kind of going over conditional statements. So I want everybody to take a few minutes. And come up with conditional statements based on the statement animals with stripes are zebras. Okay, so we should have some conditional statements, some converse, the inverse, and the contrapositive. Remember, we went over this again on Friday, trying to review everything and make sure everybody kind of understands what's going on. So for our conditional statement, we don't have it written in a conditional form yet. It's just a statement. We want to put it in a conditional. So our conditional statement is going to be, if an animal has stripes, then it is a zebra. The converse statement is we flip everything around, remember? And our converse is, if an animal is a zebra, then it has stripes. The inverse now is the negation of our original statements. If an animal does not have stripes, then it is not a zebra. And the contrapositive is either the negation and flipping of what we had, of the conditional, or we just negate the converse. So if we kind of look at it this way, if an animal is not a zebra, then it does not have stripes. Those would be your conditional, your converse, your inverse, and the contrapositive for that statement. Again, I hope everybody's kind of getting that in their head and they're understanding exactly what's happening with those statements. We'll see them a little bit more in this unit, and it will definitely be on the test for this chapter. So just make sure you do have that sorted out. Okay, deductive reasoning. It's working with deductive reasoning is typically looking at patterns and with inductive reasoning, is using patterns and observations to make conjectures. We looked at a series of numbers. What's the next number? We just looked at what had been happening. It's just all patterns and figuring out what the pattern is telling us to do, and then coming up with a conclusion or a conjecture. It is useful in math, but what we're really going to do is we want to focus on deductive reasoning, because deductive reasoning is using facts and rules and definitions or properties to reach logical conclusions from a given statement. This is really the backbone of what geometry is when we start working with our proofs, knowing all the postulates and theorems and understanding what's happening here and there, so that we can kind of come through and create bigger proofs of other types of concepts in geometry so that we understand what's happening. Here's an example. All even numbers are divisible by 2. 14 is divisible by 2. Based on what we've been told, we can come up with a conclusion that 14 is an even number. We have all even numbers are divisible by 2, which is a true statement. 14 is divisible by true, which again is a true statement. So we can then say that 14 is an even number. The illustration is showing our deductive reasoning. We're given two true statements. We're told all even numbers are divisible by 2. We're told 14 is divisible by 2. So from those rules or facts, we can then say that 14 is an even number. That's what using deductive reasoning is. It's using the information you're given to come up with a statement or a conclusion. What we're going to talk about is the law of detachment. The law of detachment is drawing a conclusion from a true conditional statement and a true statement. So just think back to our conditional statements that we've used in the past. What we're also going to be told is a true statement. So what it's going to be in the PQ format is if P then Q is a true statement, and P is definitely true, then that makes Q true. So here's our example. If a car is out of gas, then it will not start. Obviously a true statement. If a car doesn't have gas, then it can't start. My car is out of gas. My conclusion then is my car will not start because it doesn't have gas. Because our conditional statement had a true P, if the car is out of gas, then it will not start. The P part of it is my car is out of gas. That's what it's telling me. So then I know that my car is not going to start. That would be the Q part of it. So when you're kind of looking at the conditional statements, we always know, or we're always kind of going to assume that the front part is true, and then our conclusion from that will be able to look at the two statements and say, okay, yep, that statement's true. So again, it's a valid conclusion because I know based on everything we're told, my car is not going to start because it doesn't have gas. Here's another example. If two angles form a linear pair, then their non-common sides are opposite rays. AED and AEB form a linear pair. And then our conclusion is going to be that ED and EB are opposite rays. Now, when we think about what linear pairs look like, we're going to kind of think of how it all works out, and we're going to have to identify our hypothesis and our conclusion. If you want to kind of draw out an example of it so you can see, obviously do that. So if two angles form a linear pair, that's the P part of our conditional statement. The Q is their common sides or opposite rays, which if you remember what opposite rays are, it's two rays that have a common endpoint that go off in different directions, and then they're going to have a common side because it's a linear pair, so they're going to form a line. So step 2 then is because our given statement AED and AEB form a linear pair, so we're told that the two angles form a linear pair. It satisfies our hypothesis that that is true. Then the law of detachment then tells us that our conclusion statement, ED and EB are opposite rays, is also true because that's the true part of our conditional statement, and then we're told that our angles form a linear pair. So tying everything together, that tells us that that's a true statement, and it's a valid conclusion based on the information that we had. Second example, if Mika goes to the beach, she will wear sunscreen. Mika is wearing sunscreen. The conclusion then is Mika is at the beach. So again, we identify our hypothesis and conclusion. The hypothesis is if Mika goes to the beach, the conclusion is she will wear sunscreen. Now, when we look at our statements here, our conclusion, or our second statement, what we're given, is that Mika's wearing sunscreen. So we're not told that she's at the beach, we're told that she's wearing sunscreen. So the statement that she's wearing sunscreen satisfies our conclusion of the conditional. So she's wearing sunscreen, awesome, she's wearing sunscreen, but we don't know that just knowing the conclusion is true doesn't make the hypothesis of our statement true, because if she's at a pool, she could be wearing sunscreen. If she's out playing golf, she could be wearing sunscreen. It doesn't necessarily mean that she's at the beach. We do know that if she goes to the beach, she wears sunscreen, but we can't actually say that she's at the beach just by knowing that she's wearing sunscreen. Does that make sense? So this conclusion then is not a valid conclusion. Okay, your turn. Try this one out. There's a drawing. We're going to try to figure out, is it valid, come up with a valid conclusion. If we can't come up with a valid conclusion, then just write it's an invalid statement. Right? It's given two angles supplementary to the same angle are congruent. A and C are supplementary to angle B, so therefore A is congruent to C. Is that valid or not? Okay, now that you've thought about it, we can say statement A and C are supplementary to B, so we know that B is one angle, has a certain measurement. We know that A and C are supplementary to that, so they're going to have to be the same measure. Because they're the same measure by the law of detachment, we can conclude that that is actually a valid statement, that angle A and angle C are going to be congruent. Does everybody see that? If not, send me an email, we'll talk about it. Okay, here's another one. If Helen is going to work, then she is wearing pearls. Helen is wearing pearls. Helen is going to work. Okay, so from this now, we're given the statement Helen is going to work satisfies the true conditional. Knowing that she's wearing, like we say, knowing the conditional statement and its conclusion are true does not make the hypothesis true that she's going to work. Helen could be wearing pearls on a date. She could just be wearing pearls for a picture. She could be wearing pearls for other reasons. So we can't say that she's actually going to work. So this conclusion then is an invalid conclusion. Hope that makes sense. We'll work on it some more. We'll talk about it a little bit later. We're going to come back to this again at the start of the next lesson, just to reinforce it and make sure everybody understands where we're going. Okay, the law of syllogism. It's another method for deductive reasoning. The first one, we're given conditional, and then we're told that the conditional is true. We make a conclusion based on that. The Lara syllogism allows us to draw conclusions from two true statements when the conclusion of one statement is the hypothesis of the next statement. So in our notation, if P then Q is true and Q then R is true, then P then R is also true. Let me show you an example that kind of makes sense of that. So if a number is a whole number, then the number is an integer. If a number is an integer, then it is a rational number. So we see that the number is an integer is in both of our conditional statements. In one, it's the conclusion, and one, it's our hypothesis. So we have P, Q, and R are our three different statements. So based on what we've been told with the Lara syllogism, that if P then Q and Q then R, using the Lara syllogism, we can say that if P then R. So then we can say if a number is a whole number, then it is a rational number. That makes sense from all the information that we've seen. Does that make sense? Okay, here's another example just to kind of take a look at it. Form a valid conclusion from the statements we've written. If you get a job, then you will earn money. If you earn money, then you will be able to buy a car. Come up with a conclusion, type it in, we'll go over in a minute. Okay, so you've come up with that. If you get a job, you will earn money. True statement. If you earn money, then you will buy a car. Again, we can say that's a true statement because that's what you're going to do with the money. So we can come up with our conclusion then is if you get a job, you will earn money. Because you will earn money is the conclusion of one statement, the hypothesis of the next. We can deduce then that the hypothesis of the first statement and the conclusion of the second statement are also true. Okay, your turn. We get two statements. If an angle is supplementary to an obtuse angle, then it is acute. If an angle is acute, then it measures less than 90 degrees. Come up with a conclusion based on those two statements. Okay, our statement is going to be if an angle is supplementary to an obtuse angle, then it measures less than 90 degrees. We've always thought that. That's one of the true things we learned back with the angle relationships. Obtuse angles are greater than 90 degrees. Supplementary to that has to equal 180, so then we have to be less than 90 degrees. Okay. Here we go. Try this one. Given a point is the midpoint of a segment, then it divides the segment into two congruent segments. R is the midpoint of QS. QR is congruent to RS. Okay, this statement is valid. R is the midpoint of QS, so the hypothesis of the conditional is true. Therefore, the conclusion is going to be true. They've told us that R is the midpoint. To be a midpoint, it has to be between the 2 points on the same line. So then we know the two congruent segments are QR and QS. Make sense? Something we learned in the line segment section last chapter. Okay, let's try this one. If a point is the midpoint of a segment, then it divides the segment into two congruent segments. AB is congruent to BC. So now we're saying that our conclusion is going to be that B divides AC into two congruent segments. What do we think about this one? Okay, here we're going to say this one's invalid because they don't tell us the midpoint. They tell us that segment AB and segment BC are congruent, but they don't really tell us anything about that B point. The B could be off on some perpendicular that just happens to be the same distance away from A and C, so that the segments A and C are congruent, but it doesn't necessarily make that B lies on the line AC, so then it's not going to be the midpoint. We really can't say what it is. Does that make sense? We had kind of that as an example in the conditional statement the other day where I had the picture of it. Kind of go back in your notes, you can see how that would make sense to be an invalid statement. Okay, another one. This is going to be used in Lara as a syllogism. If two angles form a linear pair, then the two angles are supplementary. If two angles are supplementary, then the sum of their measures is 180 degrees. What would be our conclusion statement for this? If you can't come up with one, write that it's not valid. Okay, here we got if two angles form a linear pair, then the sum of the measures is 180 degrees. Think back to what linear pairs are. They're adjacent angles that share a common side. The other sides, the non-common sides, are opposite rays. So they form a line, so they're going to have to add up to 180 degrees. All right, try the last one here. If a hurricane is category 5, then the winds are greater than 155 miles an hour. If winds are greater than 155 miles an hour, then trees, shrubs, and signs are going to be blown down. What's our conclusion for this one? Again, if you can't come up with a valid conclusion, just write no valid conclusion. Again, here we can come up with a valid conclusion because the conclusion of our first statement is the hypothesis of the second. So we can say if a hurricane is category 5, then trees, shrubs, and signs will be blown down. Is that making sense? I'm hoping this is making sense. I hope I'm not going too fast for this. Again, we'll cover it again going forward because this is something that we're going to really kind of need to be able to piece together when we start doing proofs. Okay, last slide, last part of the notes. We're going to draw valid conclusions if possible again, and then state whether your conclusion was drawn using the law of detachment or the law of syllogism. And if you can't draw a valid conclusion, write no valid conclusion and explain why. So if a whole number is even, then its square is divisible by 4. The number I am thinking of is an even number. What's your conclusion? So what you're thinking of is the square of the number I am thinking of is divisible by 4. We've come up with that from the law of detachment because we're told our conditional statement, if a whole number is even, then its square is divisible by 4. We're told that's true, and then we're told that the number that I'm thinking of is an even number. So because our statement kind of matches the hypothesis and we know that that's true, then we know then that the number I'm thinking of we can say is divisible by 4. Remember, if P then Q, and if P is true, then we can say true. Then we can say it's true. Here's a biology question. If an organism is a parasite, then it survives by living on or in a host organism. If a parasite lives in or on a host organism, then it harms its host. What conclusion can we draw if a virus is a parasite? So again, what are you thinking about? Okay, our conclusion here is if a virus is a parasite, then it harms the host. Again, we have if-then statements. We have two if-then statements. So we're tying together the law of syllogism, which is what this one is, and we're able to state truthfully and validly that if a virus is a parasite, then it will harm the host. Hope that makes sense. Work on the homework. If you have any questions, send me an email. We'll go over it on Wednesday class, maybe if I have a bunch of questions. And then maybe we'll kind of go through some examples again on Wednesday. I haven't quite figured out what our Wednesday class will be about, but I want to make sure that we're understanding all these logical statements to help us with the proofs when we get going. So I'll talk to everybody. Have a good day off on tomorrow. There's nothing to do tomorrow on Tuesday, so have a good day, and I will talk to everybody on Wednesday.